All right, hello folks. Welcome to lesson 20. Here we're talking about the hypothesis test for a mean with the standard deviation known. So this is probably one of the easier hypothesis tests. It'd be good for us to get the procedure down here, and then we could apply it to 21 and 22. So let's do it. Little quick theory. Remember, there's a claim, and you're trying to see if that you're believing there's something wrong with that claim, and so you're going to do a sample, and you're trying to reject the null hypothesis. And so here's the steps. There's a couple things here that we need to know, though. Um, there's some assumptions that you have a random sample. It's very important. N is greater than 30, or the population is normally distributed. Very important. And remember, in this case, we know the standard deviation. Now, I want to talk about the steps for a moment. In your notes, there's two different methods. One is finding p-value, and the other one is doing what's called finding the critical value. I learned it both ways, and we're going to talk about the one, but I'll just show you how to do the other on your calculator. So there's 5 steps, 5 major steps. You're going to state your hypothesis. We talked about that last time. You're going to choose your alpha or level of significance and find that critical value that's related to that. That's very important. You're going to find your z statistic, and then you're going to compare the two. And your choices are to reject your null hypothesis or not reject it. That would be similar to saying you're accepting it. And then you're going to state your conclusion. Remember, you're stating your conclusion in words that the average person could understand, like you're an honest journalist and you're trying to inform the public about it. Now, the p-value. The p-value is really the probability under the curve in the area of interest that you are involved with in this test. So a way to look at it is p is the probability number drawn from a distribution of a sample, what the mean would be as an extreme or more than extreme than our observed x bar. So let me see if I could say that again. Okay, let me turn off my little video. Okay, so again, this right here is your population mean. Okay, it's what it is. It's what you assume. Okay, in your null hypothesis, and then let's just say you had an x bar that was really close to it. Well, you really can't you can't buck that value that much. There's not a whole lot you could say. Probably going to have to just accept that the mean actually is that. But notice over here I have my sample mean is way over here in one of the tails, okay? And the probability of that happening is pretty small. So it's extreme or more extreme than what we observed. All right, keep that in mind. Now, a couple things here. The smaller the p, the stronger the evidence. In other words, the more further out in the tail I am, the more I'm convinced that my sample mean is way above the population mean and that there is a problem. More evidence against my null hypothesis. Don't forget there's different what's called levels of significance. This is kind of like confidence, but you have 0.10, 0.05, 0.02, 0.01. And don't forget the 0.01 would be the strongest, okay? The strongest level of significance. Let's see. Okay, here's another definition of significance level. Now, the last thing they give you in this unit is the difference between statistically significant and practically significant. You may end up with a value over here. Let's say it's a new testing method, okay, that your class does better than the stated average, but yes, it's statistically different, but in order for you to change all the curriculum, change all things like they've done with math curriculum in the state of Georgia, okay, it's not worth it, okay, not until another time. So that can, that can happen. So don't forget, sometimes you need to keep in mind how things are going to relate in the real world. Okay, enough said there. Let's do a problem. Okay, so from generation to generation, the mean age when smokers first start to smoke varies. However, the standard deviation of that age remains constant at around 2.1 years. What are we talking about? We're talking about people that start smoking. Okay, and there's a mean, and then there's a standard deviation. They gave you that as 2.1 years. Okay. A survey of 40 smokers, now we're getting into our numbers, survey of 40 smokers was done to see if the mean starting age is at least 19. The sample mean was 18.1. So now this is our sample mean. Sample mean 18.1 with the standard deviation of 1.3. This is, okay. Assume that the population is approximately normal. Perform the hypothesis test and compute the p-value. Based upon your p-value, what is the conclusion if we test at the 0.05 level of significance? All right, well, so these are some facts in our problem. Let's get right to it. What is the null hypothesis? The null hypothesis is that the age at which people start smoking is 19. Okay, I'll put 19 there. Okay, you're challenging that. And so what you're challenging is you're saying that the average is less than 19. Okay, what else? Now what we're going to do is we're going to put this data in our calculator. We need to find the p-value. And we need to remember that the level of significance is 0.05. Again, if our p-value is less than 0.05, it is definitely more extreme. We reject that null hypothesis. If it's greater than 0.05, then we can't reject it. We got to keep our understanding about that 19 years of age. All right. Okay, how do we put that in the calculator? Well, we're going to go to stat, and we're going to go to test, and we're going to enter. We're going to put in our data. Remember, this was 19. That's the population standard deviation, correct? That is the sample mean and the number. Now, this part at the bottom is very important. Our alternate hypothesis is that the age is less than 19. So we're going to select that, and then we're going to calculate. You could draw if you want to. We're just going to calculate. Now, notice over here we have our, this would be that critical value. This is our p-value. This is really what we're looking for. So 0.0034. All right, now back to our problem. Remember, if our p-value is less than our level of significance, we can reject. If it's not, we cannot reject. Now, what is our p-value? 0.0034 is less than 0.05. That's just another way of saying on that left side right here, okay? This would be where the 0.05 is. We are way over here, okay? And it's very unlikely that, that's a mistake. So our mean is extremely far away from what the claim is. So therefore, we are going to what? Reject, okay? And you say, we reject 8 sub O since, and you would say P is less than A. All right, now, a last thing is our conclusion. What is our conclusion? Okay, I started it over here. We conclude that the starting age of smokers is less than 19 years of age. And you could say at the 0.05 level of significance. Level of significance. All right, so that will be a conclusion. Hope that helps you out. I'm going to take just a moment and talk about this problem. This problem is on the back side of this exercise set, and it's about college football coaches and what they believe about the players bench pressing. Some people say that the players can bench more than 275 pounds, okay? All right, everybody has this claim, right? We're going to go, we read through the problem, we have all the facts are over here, okay? And you did a sample, you found out the sample was that people are pressing 286.17. You go, wow, maybe they are doing more, okay? You know, everybody wants to believe what they want to about claims. And so here's our hypotheses. The alpha, in this case, they told you what it is, 0.025. And then we actually do it on the calculator to find a p-value, 0.13. And so that would be no, right? That would be that we're going to not be able to reject the null hypothesis. So that 275, you know, that's still sticking as to what people believe. Since P is greater than A, we cannot reject the null hypothesis. You want to say there's not enough evidence, okay, since P is 0.13, that the football players can press more than 275 pounds. So notice you got the statement to them. Hey, the 275 pounds, we challenged it, but no, not enough evidence. 275 staying. And you're also giving them a number. And this is very helpful because someone who knows more about statistics can understand what that means now, provided that we're all taught properly and we all understand it in a similar way, or a way that gets to the truth of the situation. So hopefully this problem, you know, will help you. Now, how did I put the data in the calculator? Well, I used a frequency distribution table. So the 205, I counted 3 times. This was L1 and this was L2. That's how I got my facts over here to the side. All right, enough about that. Okay, don't forget your resources that are available to you. And, you know, what other advice could I give you? On the quiz, I made a couple notes that may help you. And what I would say is just try to take your time and be meticulous. You have what is it, 15 problems on the quiz? And you know, take your time to understand the problem before you work on it, and that would be my best advice. I wish you well. Thanks.